Hey, what is up, peeps? Hey, spreading the love here with you guys. I wanted to give you a video in case you got stuck on any of these along the way. So you might have to scroll through the video a little bit to find the question that we're on, but I'm just going to start at station 1 and take you all the way through station 5. Okay, so first things first, use your spread the love hints, right? That's this document right here. And each station will have its own set of clues. Another helpful hint I'll show you on this first question. So the top chambers of the heart are known as the valves, aorta, ventricles, or atria. One thing you can do is do a Google search for some of these questions to get those answers. And we can see our what we came up with at the very top of Google here. Normal heart has 2 upper, 2 lower. The upper chambers, the right and left atria. That's ringing a bell. So we know that the answer to question 1 is D. Okay, we found that relatively quickly. Let's go down though. Now each station is going to have a combination lock or a code that you have to break with your answers. So for this one, this is a letter number correlation. So all you're going to do is, our answer was D. So our first letter we're going to put in here is the number 5. Okay, let's go back up to question 2. Question 2, the function of the heart is to pump blood around the body, bring oxygen to the body, make blood cells store blood. Now for that, we could look up, I'm hoping most of us know that the heart's main function is to circulate blood. So we won't necessarily look up that answer, but I did give you a hint on the hints page here, right? But we know that that is E. So let's go down here. E is the number 4. So we're going to put the number 4 here. Okay, so this is one of the reasons why we got to get you guys back in school, because I can guarantee none of you guys have used a triple balance scale. So this might look new to you, but this is a scale. And it has a measurement that it measures in the hundreds column, one for the tens and one for the ones. And it's broken down even smaller with little points along the ones place there. But this one seems pretty easy. We've got 360. That's right on the 4, so 364. And so our answer to that would be K. K is the number 1, so we're going to put the number 1 here. See that? K is 1. So we're going to do question 4. What is the difference between a heart cell and a rose cell? So again, I did give you a hint here. Whoops, wrong page. So if we look here, and we think of a heart cell as an animal cell and a rose cell as a plant cell, we can look down here and see some of the differences. One of the 3 of the differences: plants have cell walls. They have a permanent vacuole, and they have chloroplasts in them, which help them with photosynthesis. But that cell wall, that looks familiar to our question here. So a heart cell does not have a cell wall, and a rose cell does. So our answer for question 4 would be R, which means we need to put the number 2 in there. So let's do that. Let's see if we got it right. Hey, touchdown. We got it right. If you missed it, rewind. Cupid's arrow travels at 45 meters in 5 seconds. Again, you can use your helpful hints. I mean, I've got the formula for speed, right? Which is distance divided by time. So all we need to do, we've got 45 meters in 5 seconds. These are in meters per second. So we need to find out how fast it's traveling per second. So we just divide 45 by 5, and our answer is 9. 9 meters per second. So our answer is A, actually, is what we're going to go with for now. So let's go down. Question number 1. is actually the second letter. Check that out. That's how we do that. And so that was A. So we're going to have to kind of just remember that and kind of rearrange these as we go. In fact, I think what I'm going to do is I'm going to do question 3 next so I can get my first number and not get confused. So question 3 is our first letter that we need to unlock this lock. So I'm just going to skip to question 3. Cupid flying up whenever he flaps his wings down. So we have him going up when his wings go down. So if we look at Newton's laws of motion here, we see an object in motion, or an object continues in its state of rest or motion unless something else causes it to change. The greater the mass an object has, the bigger it is, the more mass it has, the harder it is to get it to move or change direction. That's the number 2 law. And the third law here is for every action, there's an equal and opposite reaction. Remember when our Cupid friend, he went up when he flapped his wings down. That sounds like an opposite reaction to me. So that would be our third law. So our answer is C. So again, we did question 3 because we're trying to get this first letter, right? And so that first letter was C. All right, let's do whatever letter 3 is. So letter 3, we follow the line, is question 4. So let's do question 4. How much force is a boy hit with Cupid's 50-gram arrow when it's traveling at 5 meters per second? So again, use your helpful hints. There's a formula here. Force equals mass times acceleration. So how much force? Force equals the mass, which is 50 grams, times its acceleration, which is 5 meters per second. And so we multiply those together and we get 250. And because we're calculating a force, the grams and the meters per second turn to something else called newtons, which is a force measurement. So the answer is D. And so we know that that's going to be our third letter. So we're going to put a big D right there, capitalize it. And then our last question, what was it? Question 2? Let's just double check. Yep, goes to question 2. I think we're doing it right, friends. What type of energy is present when Cupid's arrow is pulled back and ready to shoot? So when it's pulled back and ready to shoot, that would be stored energy. I think most of us would now know, especially after our magnetic field unit, that would be potential energy. So our answer is B. Our last letter is the letter B. And let's try it. Touchdown. Station 3. When dancing in the moonlight, you see a waxing crescent moon. What moon phase will you see 3 days later? So we can see our waxing crescent, and again, the moon's going to travel around, and we can see the next thing it's going to see. And let's make it bigger. So here's the sun. Here's the new moon. We've got our waxing crescent here, and it's going to continue to go around towards its full moon side over here. So if we have a waxing crescent, looks like the next thing up to bat would be a first quarter moon. So our answer is B. Let's go check our decoder. So question 1, our answer was B. We have an arrow pointing to the right. The instructions here say use U for U, D for down, U for up, D for down, L for left, and R for right. So our answer was first quarter, which was B. So we go to question 1. B is pointing to the right. So our first letter is R. Next question. A boy sets up a picnic table on the beach next to a sand dune. How are dunes formed? And again, this is one of those that you probably learned last year or the year before. So let's just do a little refresher here. So we have, where's that? There we go. We have weathering, erosion, and deposition. And our choices, our main choices, hopefully we would say that, we would think that we would know that precipitation means rain, right? And that would be a non-example. Rain doesn't just, otherwise all of Washington would be covered in a big giant beach, right? Or sand dunes. Tectonic plates, I would hope that you would remember that those are the big land masses that we all sit on. They don't necessarily cause beaches to form, to break apart sand and other substrates and rock into fine little sand particles. So it's really, I'm thinking it's either A or B. So erosion and deposition, or weathering and erosion. So if we go back to our cheats over here, we would see that erosion mainly occurs through water, and deposition is a depositing of materials that have been broken down to smaller bits. Ooh, that already sounds like a beach. Waves, bits being broken down. And now weathering and erosion. Yeah, weathering probably does have a part of forming sand dunes, but I would say the erosion and definitely the deposition, the depositing of that material, is most likely going to cause a sand dune. So our answer for this one is A. We're going to go down to question 2. A is to the right. So we know our second letter is R. Okay, a couple has a hiking adventure on a mountain. What causes mountains to form? So if we look at this little graphic again, we can see this little refresher down here at the bottom that says continental convergence. So you can imagine two land masses smashing in, being pushed, and then all of a sudden we start to develop a mountain range as they smash together. Now, that's how we got the Rocky Mountains right in the middle of our country. That's why Denver's at a mile high. So let's go back. So yes, convergent boundaries is an option. So C is our answer. So question 3 is C. And that one's going down. So we put the letter D for down. Last but not least, what is the force that keeps people from floating off the ground to cloud 9? Is it friction, gravity? Is it electrical force? Or is it tension? I would hope by now we should all just instantly gravitate towards the right answer, right? So our answer is B for question 4. That is going to the left, and we are going to push, boom, left, and hit next. And not too shabby. Station number 4. In which biome or habitat would a white teddy bear best be camouflaged? The rainforest, the desert, the tundra, or a deciduous forest? So if we go to station 5, we can see a little example here of some biomes. We've got forests, desert, we've got grassland, we've got tundra. And notice tundra, that's usually a lot colder near the poles. A lot of ice and snow can occur there. So I'm guessing the white teddy bear would most be camouflaged or able to be hidden if it was in the tundra. So the answer for question 1 is C. For this one, we get to spin the wheel of fun. Question 1 is C. So that decoder ring is telling me that the number is actually 5 that we want to use there. Question 2. Which of the following is a biotic factor you may interact with on Valentine's Day? Yes, I gave you some hints over here, but I want to teach you some grammar, some language arts. So a lot of you have studied Greek and Latin roots in your ELA classes. This is why it pays off. If we look at this word biotic, we have the word bio. From our Greek and Latin, we would know that that means life. And from our ic, IC, it just means pertains to or has to do with. So we know biotic is something that has to do with life or pertains to life. So let's read this sentence now that we know what biotic means. Which of the following is a biotic factor you may interact with on Valentine's Day? Or which of the following is a factor that has to do with life you may interact with on Valentine's Day? Or in other words, which one of these things is a living thing? E, flowers. Absolutely. So question 2, we're going to go to E. The answer is 2. All right, let's go to question number 3. Why is releasing balloons bad for the environment? I didn't really give you a hint on this one. My hope is that we would know or have heard or learned about the fact that those balloons can end up in the ocean or in other waterways where those creatures that habitate there can mistake them for food and become ill, sick, or even die. So the answer for question 3 is K. So if we go to question 3K, that would be a 3. And question 4, last one. Identify a producer that you may encounter when picking flowers in a wildflower field. So I did give you some hints. It's been a while since we learned about producers and consumers and decomposers. But we could look at those pictures there and pretty much get the idea. But the mushrooms, if you look back there, you'll see are the decomposer. Consumers would be the rabbit and the snake, and the sunflower would be our producer. So that answer is T. So if I go to question 4 and I find T, the number is 4. So I'm going to enter 4 there. All right, last one, friends. Here we go. And again, I'm not sure how much chemistry you had, how much you studied the periodic table of elements, but I gave you a hint in the hints here. If you look carefully, the word chocolate has element symbols. How many elements are in the word chocolate? And one of the keys was the elements will always be capitalized. So one strategy could be to simply count up how many capital letters there are. C, H, C. Ooh, but that could be a different element, right? I mean, that could be the same element as over here, or a different one. L and T. So far it looks like 5, but we're gonna have to go deeper. If we go over here to our periodic table of elements, we can actually find some of those letters. C for carbon, or H for hydrogen, or, well, hold on. Let's check something here. Oh, but the O is not capitalized, so we know that's not oxygen. There is a C and then an O, though. And if we go back here, I'll bet you we could find a CO somewhere in here. Oh, look, CO. That's cobalt. So now we have C. We've got carbon, hydrogen. We've got cobalt. Ooh, there's an L and an LA and a TE. So let's see if we can find any of that. Either an, oh, let's see here. Oh, there's the TE, tellurium. And down there we found lanthanum. So it looks like the C, the H, the CO, the LA, and the TE are all elemental symbols. So their answer there is 5. So we go down here, and here's the keypad. So the answer was C. And when we plug that letter into the keypad, into the phone here, we see that's the number 3. So we're going to put a 3 right there. And let's go up to question 2. Sometimes it helps to zoom in. Control plus is your friend. So how much of the secret ingredient below is added to make love potion? 9, 10, 11, or 12? So we can see we have a graduated cylinder here. And we can see the little tick marks that line up at the 30, the 20, and the 10. But it doesn't look like this, the secret ingredient in this potion is all the way up to the number 10, right? Otherwise it would be colored all the way around there. So it looks like 9. So we're going to go down here. Our 9. So our answer is E. So we're going to go down here, find the letter E, and there it is. It's a 1. So let's enter 1. So awesome. We're going to solve this. We're going to escape this escape room, friends. Question number 3. In which of the following is an example of a chemical change? So you can go to your helpful hints. Oh, jeepers. You can go to your helpful hints here. And I did put just a reminder of what's the difference between chemical and physical changes here. The main difference is when you have a chemical change versus a physical change, you have a new substance when it's all said and done. So we can go through each one of these and kind of test, like, is this something new? Or is it the same thing? So let's start at the bottom. Cutting a cupcake to share. Hey, I'm going to cut this cupcake in half and give you a bite. Does it still taste like a cupcake? Then it probably isn't a chemical change. It's a physical change. All you did was cut it. It's still the same thing. Still tastes like a cupcake. Now, dipping strawberries in melted chocolate might make them taste different. You're right. But is the strawberry underneath the chocolate the same? When you put on clothes and a coat and you go outside to go play in the snow, is your skin underneath still skin? Yeah, nothing's really changed. You just put something over the top of something else. Coloring a Valentine's Day card. Okay, so you got a card, you color it, and you give it to somebody. I'm pretty sure they're not going to think, well, it's a red card, so they're going to think it's an apple, right? It's still a card. It's still made out of paper. Still the same stuff. Baking a heart-shaped cookie. Okay, so think about that. You got your milk and your eggs and your flour and your sugar, and you mix it all up. Throw it in the oven, bake it, and you get this nice heart-shaped cookie to share with a loved one. But can you take the milk out of it and then drink that milk? Can you take the egg out of it? No. So that would be a chemical change. So J is our answer for question 3, and J is the number 5. Woohoo! Doing well. Last one. Which piece of jewelry contains the element with the highest atomic mass? So again, I did put this in your hints here. So we have our atomic mass number right at the top. And what's interesting is as we travel down the periodic table, we'll see we've got like a 1, a 4, a 6, a 9, 10, 12. They keep getting bigger as they go up, right? So now what we need to do is we need to take a look, just like the question said, we need to take a look at gold, platinum, tungsten, and silver and see which one has the highest atomic mass. So we've got silver here with 47. We've got tungsten with 74. Ooh, that's a inverse, weird. Platinum with 195. Oh, yeah. And then gold at 196. I think I misspoke. Sorry. Silver is at 107, right? There's the atomic mass way up at the tippy top, that little number. Tungsten is 183. Platinum is 195. And gold just barely beats it with 196. So it looks like gold earring or the gold chain necklace will have the highest atomic mass. So our answer is R. We go in here, we find the R, and that number is another 5. We hit that next button, friends, Guess what? Congrats, peeps. Give your verification code to Mr. Roberts to be dismissed. Of course, if you're on the Zoom, if not, most of you watching this probably aren't on the Zoom. And then there's your secret code. And then push that little submit button down at the bottom, and you are done, friends. All right. Good luck. And I hope that was helpful. Until next time, go have fun in the snow, friends.